Welcome. Okay, today what I'm going to be doing is I'm going to be addressing Newton's three laws. So, his first law, a moving object will continue to move at the same speed and direction unless an external force acts on it. A stationary object will remain at rest unless an external force acts on it. This was Newton's first law, and I want to explain it further by giving some models, giving some examples. When I was a kid, me and my cousin Shabia Yassin, who I hope is watching, we spent endless hours playing with these car toys. And at that time, Gran Turismo wasn't out. So we used to be like, oh, I can't wait to play. So we used to play with our hands and move these cars along tables, along the floor, wherever. Now, how does this fit in with Newton's first law? Well, it does. If we didn't touch the car, or we didn't move it with our hands, the car would remain stationary. It wouldn't move. It was only when an external force, i.e. me or my cousin, when we moved it with our hands, that the car would actually move. So that actually represents Newton's first law. It's also important to understand if me and my daughter were having a tug of war and I pulled with 75 newtons and she pulled with 10 newtons, who would be the victor? Of course, I would win because the resultant force would be 75 minus 10 and the answer would be 65 newtons to the right. I would beat my beloved daughter at a tug of war. Let's look at Newton's second law. The resultant force of an object is equal to the mass of the object multiplied by the acceleration of the object. Now, it's very important to understand this triangle FMA, force, mass and acceleration. We're going to have a go and see if we can work these out. Now, we also understand that force, mass and acceleration are all linked together. I remember hearing about a story about how this Subaru Impreza, which is relatively quite a light car, got away against the police chasing them. The guy fit in a Lamborghini engine within the Subaru, allowing the Subaru to have more force. Think about it, the mass isn't a lot, it isn't substantial, and that's why cars like the Golf GTI, the Citroen Saxo modified, a lot of these small cars, the Mini Cooper modified, are really fast cars. It's because their mass isn't a lot, but their force, they pack a punch. Now, let's see if we could calculate this. Let's say, for example, each block has a mass of 5 kilograms. Work out the acceleration. Now, to work out acceleration, if I just cover acceleration, I know I have to do force divided by mass. Okay, so the force, work out the difference between 14 and 20, it's 6. And divided by the mass, which is 5. So I'll have to do 6 divided by 5 and I'll get an answer. Let me know, you pause the video, have a go at the other two, see if you can work it out. Okay. Here's the answers to them questions. For the first one, the force is 6 because of the difference between 20 and 14. And then I just worked it out. The answer was 1.2 to the right. Second one, 1.2 to the left. And finally here, the force was 8 because the difference between 16 and 8 is 8. I then did force divided by mass equals acceleration. So I did 8 divided by 5 and the answer was 1.6 meters per second squared to the left. Okay. Let's have a go at this question. A car of a mass of 3,500 kg is accelerating at 5 meters per second squared. What is the resultant force? Force equals mass times acceleration. What's 3,500 times by 5? And the answer is over there. 175,000 newtons. Okay, last but not least, what was his third law? For every action, there exists an equal and opposite reaction. What he meant. Okay, let's say for example, you've got a box on the floor. Okay, now as you know, a box has a weight. Let's say the box is on the floor, it's on the ground, it has a weight. Believe it or not, the force of weight is keeping that box on the ground, but equally, there is another reaction called a normal. Some people call it a reaction force. There's something keeping that box upright. Why is it not falling through the ground? Because the ground also exerts a force. Look at this example here. We've got a man here sitting on a chair. The man is exerting a force on the chair, okay? And that is the man's weight. However, there is a force coming from the chair keeping the man upright and not falling through, and that is called a reaction force. And that's what the great Newton meant in his third law. Look, for every action there exists an equal and opposite reaction. That's what he meant. So if I suddenly start leaning on the wall, why am I not pushing the wall through? Is because the wall is also giving a reaction force that's making sure that it's keeping me just leaning on the wall and not going right through it. Thank you very much for watching, and please like and subscribe.